Okay, today we're going to do Unit 4, Notes number 8, which is our graphing or inequalities. So with graphing or inequalities, it's super similar to whenever we're just graphing, whether it's in standard or y equals mx plus b form. But with this, we have our line could be solid or dashed, and we have to shade either above or below the line. So those are the only two differences. So the first thing we have to know whenever we're graphing inequalities is we have to determine if what's going to be a solution and what's not going to be a solution. A solution of an inequality is a point that makes the inequality true. So any point in the shaded region is going to be true for that inequality. So it says, which of the following points is the solution of the inequality? So whenever we have a set of ordered pairs, we have an x and we have a y value. So we're going to plug those in for our x and our y. So we're going to have 4 times our x value, which is 0, plus 3 times our y value, which is 2, greater than or equal to 12. And then we just simplify this. 4 times 0 is 0. 3 times 2 is 6, greater than or equal to 12. 6 is greater than or equal to 12. Is 6 greater than or equal to 12? No. So that is not a solution. So let's try the other one. We're going to do 4 times our x value, which is 3, plus 3 times our y value, which is 0, is greater than or equal to 12. So we're going to have 12 plus 0 is greater than or equal to 12. So we're going to have 12 is greater than or equal to 12. Is 12 greater than or is it equal to 12? Yes, so this is a solution. So if it makes it true, it's a solution. If not, it's not a solution. So how are we going to graph these? So if you have a greater than or equal to or a less than or equal to, so your line is underneath your inequality sign, you guys remember that it's a solid dot. So this means it's going to be a solid line. So if there's a line underneath of it, it's going to be a line. It's like equal to the point or line. So anytime we have if you are given a point that's on a solid line, it is a part of the solution. This shows that the boundary is part of the solution. So let me know if you guys have any questions on that. And we're going to do some examples so it'll help clarify what I am meaning by that. Okay. Now we have our inequality, which is greater than or less than. So there's no line. So remember, this is an open dot. If it's an open dot, it's going to be a dashed line. So a dashed line is going to just look, you're just going to have a dashed line. As long as I notice that it's not solid, you're good. So we do not include the pointer line. This shows the boundary is not part of the solution. Solutions, I guess. So if a point is on a dashed line, it's not a part of the solution. So let's go down and graph a couple. So we have y is less than 2x minus 1. So if you put this in your graphing calculator and get your table, that is more than okay to do. Or you can graph it using slope and y-intercept. So if we get our table, so then if we're going 1, 3, -3, negative. So our first point, if you use your calculator, is -2, -5, -1, -3, 0, -1, 1, 1, and 2, 3. Now, before you draw anything, you have to remember, is this a dashed or solid line? This is going to be a dashed line. So we're going to draw a dashed line. So we're going to put just dash marks. And then we have to figure out, do we shade above or below? This is a less than sign, so it's pointing towards lesser numbers, so we shade in the less than part. which is going to be below because it's less than. So we got a shade in the less than part. And it doesn't have to be perfect, you guys, as long as I see that you shaded below the line. So is 0, -1 a solution? So 0, -1 is right here. If you guys remember, if it's on a dashed line, it is not a solution. So is this a solution? No, because on dashed line. Oops. Okay, the next one. Well, this one's not in y equals form, so we're going to have to get it there. So I actually, on this one, if you, no, let's get it into y equals form. So we're going to add x. So you're going to have 2y is greater than or equal to x minus 4 because we can't combine them. Then divide both sides by 2. Y is equal to, x divided by 2 is the same as 1/2 x. And then minus 2 because there's a 1 right there. Okay, and then if you put this in your calculator, you get your table. -2, -1, 0, 1, 2. So we're going to have 0, -2. And then this one, because you're going... Hold on, I just messed that up. Sorry, I'm trying to do this in my head without a calculator, you guys. So 0, -2. So this one we're going to be at like -1.5. So this one will have decimals. So if you want to skip those decimals, you can. Okay, so we're going to have -2, -3, -1, -2.5, 0, -2, 1, -1.5, and 2, -1. Now, this one we have to figure out, dashed or solid. This one has a line underneath, so it's solid. So we're going to draw a solid line. Oh my goodness, you guys, I cannot draw today. Okay, so solid line, and then we have to figure out whether we shade or below or above. So for y's right here, we have a greater than or equal to sign. So if it's greater than, we're going to shade above because it's all the greater than numbers. So get close to your line, and then it's everything above in the graph. So then we have to go down as 3, 2, a solution. So let's go graph 3, 2. 3, 2, is it in my shaded portion? Yes. So is the solution? Yes. Because in shaded region. Okay, let's go to the back. We're going to do some more graphing. Okay. So determine if the following points are solutions. So we're just going to plug them in. So we're going to have, this is our x and our y. So we're going to have 3 is greater than -2 times -1. Ooh, what did I just do? Hold on just a second, you guys. Okay, and then we're going to have -2, and then we plug in x. We'll plug in our x value right here. So -1 and then -1. And then we're going to simplify this. 3 stays the same. -2 times -1 is a +2 minus 1. So you'll have 3 is greater than 1. Is that true or false? That is false. So that means that that is not a solution. Damn it. Okay. And then on this one, we have our x and our y. So we're going to plug in 0 for y, -2. Hold on, you guys. Sorry about that. I'm trying to do these at home. So -2, and then we're going to plug in our x value, which is -8, and then -1, and then we're going to simplify. So 0 stays the same. -2 times -8 is going to give me a +16, and then minus the 1. So we're going to have 0 is less than 15. Is that true? Yes. So that means -8, 0 is a solution. Another way you can do this is you can always graph this in, you can graph it in your graphing calculator, and you can determine, okay, which way am I shading, and is that point in the shaded region? So if you don't want to plug it in, because I know it's kind of tricky, just keep that in mind. Okay, we have to graph these inequalities. So these two are both in what we call standard form. So we have to find our x and our y intercepts. So we're going to have x is greater than 2. We're going to have, we can just get rid of the inequality sign. So x equals 2. So our x-intercept is 2, 0. Then we're going to have negative y is equals 2. So that means our y-intercept is going to be -2. Oops, wrote that backwards. 0, -2. So graphing this, I need to look at dashed or solid. This is solid, and then we're going to figure out where to shade. That's a greater than, we're going to shade above. So we have 2. 2 is our x, right? Yeah, 2 and -2 is our y. And we said this is going to be a solid line. Okay, and then it is greater than, so that means we want to shade everything above, because it's everything greater than those points. And that's what it'll look like. Okay, you guys, I am sorry. I just did that one completely wrong. Okay, you are right on the so this one you can find the intercepts. However, whenever it's in this form, we have to make sure we rearrange it. So if we subtract the x over, get it different. We're going to get negative y is greater than or equal to negative x plus 2. Then whenever we divide by that -1, if you guys remember, anytime we divide by a -1, it flips the inequality sign. So the only thing wrong with this one is because that inequality sign was going to get flipped, I shaded in the wrong direction. Because eventually it will be less than, so it needs to be shaded below. So keep that in mind, okay, you guys? So the next one, this one, it would be a lot harder to find the intercepts because you have 2x plus y is greater than 5. And you can't, 5 divided by 2 is not going to simplify. So we're going to subtract the 2x over. This is going to give us y is greater than -2x plus 5. And then we can put this into our calculator to get our x and our y. So -2, -1, 0, 1, 2. We're going to 0, 5. 1, 3, 1 or 2, 1, 7, 9. Okay, graph this. So whenever we plot these points of -2, 9, -1, 7, 0, 5, 1, 3, 2, 1. Okay, now we have to decide, is it dashed or solid? Looking at this, there's no line underneath, so it's going to be dashed. So let's graph our dashed line. Then we have to decide which way we're going to shade. And we want to look at our final equation to decide. So this final equation is a greater than sign. That means we're going to shade in the greater. So everything above this line is going to be shaded. Okay. Oh, and I got to answer the bottom two questions. Okay. Is point 0,2 a solution? So on this one, 0, 2, 0 up 2. Is that in the shaded portion? No, because not in shaded. Next one is 1, 5, a solution. So go over 1, up 5. That is in the shaded region. So yes, because in shaded. So it's solution if it's in the shaded. If it's not in the shaded, it's a solution. So sorry about number 2, that first one, you guys. Sorry I goofed on that one. But let me know if you guys have any questions. Okay, last one. What is the slope of this? And then what type of transformations? So if we have to find the slope, we have to convert it. So we're going to distribute. And then we're going to move this 5 over to get it in y equals mx plus b form. So we're going to get y equals negative 2x plus 3. Our slope is going to be negative 2 because it's next to the x. Now, what transformations are occurring? First thing we look at, negative sign. So there's a reflection over the x-axis. We look at the 2. It's bigger than 1, so it's a vertical stretch by 2. And lastly, we look at the plus 3 on the end, which means it's a shift up 3. Okay, let me know if you guys have any questions over that note. You guys can get started on the homework.